Google just revealed something wild, an AI system called VISTA, and it's changing what video generation even means. This thing doesn't retrain, doesn't fine-tune, and doesn't wait for updates. It simply learns from its own mistakes every time you use it. Each run makes it smarter, cleaner, and more cinematic than before. And in Google's internal tests, VISTA actually beat VEO 3, their previous flagship video model, in 60% of comparisons. That's not just progress, that's evolution happening in real time. So here's what's really going on. VISTA takes your idea, a sentence, a paragraph, whatever you give it, and turns it into a structured plan before it even starts generating anything. It breaks that idea into scenes and assigns each one 9 specific traits. How long it lasts, what type of scene it is, who's in it, what they're doing, what they're saying, what the world around them looks like, how the camera moves, what sounds play in the background, and the overall mood. Instead of guessing what the model might output, VISTA builds a full roadmap and then runs multiple candidate videos through a kind of tournament. Each video competes head-to-head in pairs, and the winners move on. Before the judging begins, VISTA writes something called probing critiques. These are short analyses explaining what worked, what broke, and what the AI noticed about the scene's structure, visuals, and logic. It's not judging blindly. It's thinking through each result before making a call. When a round finishes, the top video doesn't just win, it moves to a second stage where a panel of specialized judging agents takes over. There are 3 categories of judges: visuals, audio, and context. And each one has 3 roles: a normal judge that scores performance, an adversarial judge that hunts for weaknesses, and a meta judge that combines both opinions into a final decision. The visual team looks for image clarity, motion stability, focus, and temporal consistency, basically whether it looks real and natural. The audio judges analyze sound quality, synchronization, and unwanted artifacts. The context judges handle logic. Is the story coherent? Do the actions make sense? And do transitions feel smooth? Once that's done, VISTA calls in its main brain, the deep thinking prompting agent. This is the part that actually rewrites the prompt. It doesn't just tweak a few words, it goes through 6 reasoning steps: identifying what failed, defining what success looks like, checking for missing detail, deciding whether the problem came from the model or the prompt, finding vague or conflicting language, and finally proposing concrete improvements. Then it generates new prompts, makes new videos, and the loop repeats. By default, it goes through 5 total cycles, 1 initial round, and 4 self-improvement loops. Each cycle samples 5 prompts, creates 3 variants of each, and produces 2 videos per prompt, making about 30 videos per iteration. It's a lot of computation, but every loop brings visible improvement. On benchmarks, the results speak for themselves. VISTA was tested on a single scene dataset of 100 prompts and a multi-scene internal dataset with 161. Compared with direct prompting, where you just feed a raw text into VEO, VISTA's refined approach produced far better videos. By the 5th iteration, it won 45.9% of single scene tests and 46.3% of multi-scene ones, a margin more than 30 points higher than the baseline. They also compared it to other optimization tools like Visual Self-Refine, Google Cloud's rewrite system, and VPO. Those alternatives gave inconsistent results. Some even got worse with more iterations. Visual Self-Refine started strong but quickly plateaued, VPO bounced around, and rewrite was unpredictable. VISTA, on the other hand, kept getting better with every loop, proving it was actually learning instead of just getting lucky. To double check, 5 professional prompt engineers compared VISTA's results with those from the best competing models after 5 iterations. VISTA won 66.4% of those matchups. When experts rated full optimization runs on a 1 to 5 scale, VISTA averaged 3.78, while the next best scored only 3.33. Breaking it down further, the visual quality jumped from 3.36 to 3.77, and audio quality from 3.21 to 3.47. The differences might look small, but they add up when scaled across entire video sequences. And even though individual preferences varied, some evaluators valued realism, others smoothness or sound, they consistently picked VISTA's outputs as the best. Behind the curtain, it runs on Gemini 0.5 Flash as the multimodal reasoning engine and VEO 3 as the video generator. Even when they swapped VEO 3 for the weaker VEO 2, VISTA still boosted quality, 23.8% win rate for single scene and 33.3% for multi-scene tests. That shows the framework itself is doing the heavy lifting, not just the generator. Each iteration uses about 0.7 million tokens on average, mostly during the tournament phase because every video input is over 2,000 tokens. It usually generates around 28 videos per loop. Sure, it's compute heavy, but the more resources you give it, the better it performs. When researchers pushed VISTA through 20 iterations, it just kept improving, while other methods plateaued. Even a lighter version running on the multi-scene dataset continued climbing long after the competitors stalled. They also tested what happens when you remove pieces of the system. Without the scene planning, the visuals lost consistency. Without the tournament stage, results got unstable. With only one judge, the logic fell apart. And removing the deep thinking agent stopped progress entirely. Every single part of VISTA's design matters. One of the most impressive results was how it handled hallucinations. VEO3, like most video models, often adds things that weren't requested. Random text overlays, unwanted music, or objects appearing and disappearing mid-shot. VISTA cuts this down dramatically by enforcing strict planning rules and applying penalties if those rules are broken. If captions appear when none were asked for, the video loses points. If characters move unrealistically or objects vanish, that clip is downgraded. The end result is cleaner, more coherent footage. VISTA also got much better at following detailed instructions. In one test, the researchers asked for a factory scene with a blade battery on a conveyor belt, a yellow industrial robot, and a screen showing a yield percentage in simplified Chinese. Normal prompting missed the details completely. VISTA delivered everything perfectly, the layout, robot, and text. In another example, they requested gremlins riding a wooden roller coaster moving forward while the camera tracked backward. Standard prompting messed up the directions entirely. VISTA fixed it, producing a shot that looked logical and physically correct. This approach is part of a larger movement in AI research known as test time optimization. Instead of building larger models or retraining them endlessly, the focus shifts to using computation at inference, letting the system refine itself while it runs. OpenAI has been exploring it for reasoning models, and now Google's applying the same principle to video. According to the research paper, VISTA is the first black box test time optimization system for text-to-video generation. Earlier approaches either required internal model access or focused on narrow goals like object detection or safety. VISTA unifies all of it, visual, audio, and contextual refinement in one continuous feedback loop. There are still limits, of course. The judging agents depend on multimodal LLMs, which can introduce bias. Human evaluations help, but they're expensive and can't scale infinitely. Some quality metrics assume a specific cinematic style that might not apply to every project. And VISTA's success still depends on how good the base models are. It can't surpass their fundamental capabilities. Still, the impact is undeniable. VISTA outperformed VEO3 in 60% of trials, won 66% of expert comparisons, and showed steady improvement without retraining. It followed instructions more accurately, produced smoother multi-scene sequences, synced audio and video seamlessly, and dramatically reduced hallucinations, all during test time. But if this kind of system keeps evolving, it could completely change how we make video content. Production could become faster, cheaper, and far more accessible. Each run becomes its own lesson, every iteration a step toward perfecting the craft automatically. So maybe this isn't just a better AI, maybe it's the start of self-improving filmmaking, where the machine learns to direct itself, scene after scene. Let me know what you think down in the comments. Don't forget to subscribe, and I'll catch you in the next one.